Hello, everyone. Uh, Here we are for another exciting day of physical science. I can see a few of you have viewed the lectures online, which is great. Today is going to be pretty much half the lecture because we have a test this week. So I don't because the test is considered part of lecture time. You won't be required to know all about it. So, okay, let's go through this PowerPoint, and then I have a few questions at the end. I kind of tie this chapter into some history. So let's see. Okay, first off, this is Chapter 8, Atoms and Periodic Properties. I forgot to list the SI's availability, but I'll do that. Maybe I'll post it online. It's the same as it has been all semester. So basically, here in like the early 1800s, they started wondering if there wasn't an atomic structure. And all these fields of study were kind of trying to figure out more about their field of study. Like electricity, they were trying to figure out what caused electricity, and they figured out it was electrons. And then the nucleus came from the study of radioactivity, because they discovered that the nucleus was a really small part of the atom. And then the study of light helped the discovery of mini solar system. And by that I mean an electron that rotates around an atom. I want you to know that the discovery of the atom and its structure came from multiple fields of study. So here we go. The atomic structure was discovered. How could we study something so small as 1 gram of hydrogen atoms? That's what took so long. It's so 1 gram of 1 gram of hydrogen atoms contains 6 times 10 to the 23rd atoms, which is amazingly small. So the cathode ray helped discover the electron. What the cathode ray was a positive and a negative terminal set up in a vacuum, so that I really just need to pull up a picture of a cathode ray. Let's see. And as you can see on this diagram, let me see if I can't bring up a better one. Well, as you can see, there's a positive terminal and a negative terminal. And in the middle here is a vacuum. And so around it is connected to a circuit, so that there's a potential energy difference. So a ray wants to jump from the negative terminal to the positive terminal, and that's what happens. So what was in this air was what the scientists were trying to figure out. They were trying to figure out what was electricity. And then a scientist by the name of J.J. Thomson discovered the electron, that the electron was in there. Later it was discovered that the electron weighed about 1/1840th of the mass of the lightest atom, hydrogen. So they discovered that the electron was a really, really, really small part of the atom. But if electrons are negative, what balances them out? I mean, the atom is neutral. Most atoms try to be neutral. So there has to be something in the nucleus, and that's what they discovered next. The nucleus, discovered by the use of radiation. Electrons orbit the nucleus at a distance 100,000 times the radius of the nucleus. So really far away. Imagine the Earth and the Moon. So protons and neutrons were discovered. Protons were discovered first because they knew something had to balance out the electrons. But then they also postulated that there's a neutron in the atom too. So, but you need to know that the number of protons of an atom make up the atomic number. And hydrogen has an atomic number of 1. So it's basically just a proton. You get that? Because a proton is 1. Hydrogen has an atomic number of 1, so it's basically just a proton. Now if it's neutral, it also has an electron on it. Changing up the number of neutrons of an element creates different isotopes. So, just to go over that, adding neutrons to an atom changes the number of isotopes, or creates different isotopes. Changing up protons will change the atomic number of it and the element. So, E equals H times F. H is Planck's constant. This is a formula, obviously. This helps derive the frequency and energy. It helps derive the relationship between frequency and energy. Remember, on the electromagnetic spectrum that we went over last class, if you can remember that really wavy thing that included microwaves and radio waves and gamma waves, and Roy G. Biv, which was visible light, remember that if you increase frequency, meaning it jumps up and down real quick, you increase the energy. Now if it's really slow frequency, that has less energy. So higher frequency light, such as ultraviolet light, has more energy than lower frequency light, such as red light. So here we go. We have Roy G. Biv right here. Red has lower frequency and lower energy. Violet has more energy and a higher frequency. As you move to the right, the energy increases along with the frequency. So what is the energy of a photon of red light with a frequency of 4.6 times 10 I'm going to do this problem real quick with you. Let's see. Okay. So we have energy. That's what we want. As you can tell in this problem, what is the energy? There's energy right there of a photon of red light. Well, Planck's constant, when it says constant, it's going to be constant, which means the same thing. So every time. So E equals whatever H is joules times seconds. Oh, and that's times 4.60 times 10. Oh, that's what we got from the problem. So energy will equal, let's see, joules. Now remember, remember this is joules times seconds. And hertz over here, which is what I just gave you. Hertz is per second. So the seconds cancel, and all you get left, 6.63 times 10. Times 34th. Joules. The good old term joules comes back. So basically, and I'll probably give you Planck's. No, I'll tell you what. You have to remember Planck's constant. It's going to be something you have to memorize. Let me button up a little bit. Sorry, I get a lot of prank calls throughout the day. So, okay. Now let's go over Bohr's theory. Niels Bohr. Maybe I can show a video on that. That would be good. Okay. Because I sometimes try to show videos to kind of expand your horizons. So, Bohr's theory. An electron revolves around an atom only in a certain allowed orbit. Electrons staying in the same orbit, they don't emit energy. So an electron rotating around an atom, if it's not moving orbits, it's not emitting. Emitting means giving up or gaining energy. An electron gains energy when jumping to a higher orbit, and it loses energy when falling to a lower orbit. You can kind of think that if this electron's really got energy, it's going to be really wanting to get away from that atom. It's kind of one way to think about it. Or you could just remember that an electron, as it gains energy, it moves to higher and higher orbits. So they came out with something called quantum mechanics. Pretty awesome. It describes the energy state of an electron. The distance from the nucleus. So there's 4 things that describe the energy state of an electron. Higher the number, farther from the nucleus, and higher the energy. That's going to be the first number. It's going to be like n equals 1 right here. And then there's also an energy sublevel, SPDF. Farther to the right, higher energy. Now, am I going to want you to know how many orbitals a 2sd35 atom has? No, but I would like you to know what's on this screen right now. Right here. You can look in the book and get freaked out, or you can just stick with what's on this PowerPoint. The distance from the nucleus. Higher the number, farther from the nucleus. And the higher energy. So a 4s orbital has more energy than a 1s orbital. That might be good to know too. Orientation in space. Some orientations have more energy than the others. And the direction of spin. So periodic table. I want you to memorize the first 10 elements and their atomic number. So that means hydrogen, helium. Let me see real quick. Where's my periodic table? Here we go. Hydrogen has an atomic number of 1. Helium has an atomic number of 2. Lithium is 3. Beryllium is 4. Boron is 5. Carbon is 6. Nitrogen is 7. Oxygen is 8. Fluorine is 9. And neon is 10. Please be able to point to the metals, nonmetals, and also semiconductors. So, let me think. Well, metals shouldn't be too hard because if you just remember what one metal is, let's see. Silver. Silver's a metal. There it is. Zinc, Zn. So you should be able to point to metals. Semiconductors. That's what's in between. Semi. Just remember semi's in between. So that's right there. And nonmetals. You can remember oxygen. Oxygen's not a metal. Elements from the same column of the periodic table will often have similar properties, such as lithium, sodium, and potassium. I know that sometimes sodium and potassium are interchanged as salts. That's table salts. Also, fluorine and chlorine are similar, and they're from the same periodic table column. So, let's just go over a review of dates real quick. Early 1800s, atoms were discovered. 1897, the cathode ray tube determined existence of electrons. 1907, the nucleus was discovered. How was it discovered? Anybody remember? Radiation, yep. Quantum mechanics was discovered in 1923. In 1938, a guy by the name of Meitner discovers nuclear fission, which just set the whole physics world on fire. 1939, Einstein wrote a letter to Roosevelt. Now, why would it be important that Roosevelt knew about this project? Plain and simple, the presidents of the United States can spend a lot of money on research of their choosing. If I mean, of course they have to get Congress to go along with it if it's a lot of money. But I'm guessing that they got this going. And 1939, the Manhattan Project started. I'll describe the Manhattan Project later. 1945, Trinity was first nuke successfully tested. In 1945, Enola Gay dropped a little boy on Hiroshima, killing a lot of people. This is just a copy of a summary of the letter that Einstein wrote. As you can see here, he says, it is possible to set up a nuclear chain reaction in a large mass of uranium. This new phenomenon would also lead to the construction of bombs, and it is conceivable that extremely powerful bombs of a new type may thus be constructed. So, right here it also warned about Germany possibly having nuclear bombs. Now, half the reason you want a nuke is, well, I'm not going to go over that in this class. Here's the Trinity Test Project. That video I'll put online. Manhattan Project began in 1939. It grew to employ 130,000 people. Most had no idea what they were doing, but they were successfully splitting the atom and creating a lot of power. The problem was a lot of those people probably would not have been okay with developing a nuclear bomb. Successful testing of bomb in 1945. And then the first bombs were dropped in 1945. So let's just go over some questions real quick. Cathode ray tubes help to prove what? The existence of electrons. The volume of an atom is mostly what? Space. So the volume of an atom is mostly just plain space. It's like a empty space. So you have your electrons floating around the nucleus. The nucleus is tightly bound, and there's just a lot of space. The atomic number is the number of what? Protons. All neutral atoms of an element have the same what? Same number of protons and electrons. Atoms of an element that have different numbers of neutrons are called what? Isotopes. The sum of the numbers of protons and neutrons in the nucleus of an atom is what? And I actually forgot this real quick. Let me see. The mass number. And that's what's included in the on the periodic table. The atomic mass. Like for instance, let's see. Oxygen has an atomic number of 8 and an atomic mass of 16, meaning it's got 8 protons and 8 neutrons. Let's go over nitrogen. 7. So it's 7 protons, 7 neutrons. Fluorine is 9. But it also has 10 neutrons, so it's 19. That's all good stuff to know. So the sum of the numbers of protons and neutrons in the nucleus of an atom is what? I just went over that. Okay. The gain or loss of electrons from an atom results in the formation of what? Ions. Not isotopes, but ions. And this should be the end of the lecture. I'll post some videos for you to watch.